So guys, let's continue speaking about Rust, programming language that we already spoken previously. So guys, let's go. What are you gonna speak now? About memory management of Rust. Rust doesn't use automatic garbage collection. Memory and other resources are managed through the resource acquisition is initializing convention. With optional reference counting, Rust provides deterministic management of resources with very low overhead. Values are allocated on the stack by default, and all dynamic allocations must be explicit. There is the concept of references using the "and" symbol, which does not involve runtime reference counting. The safety of such pointers is verified at compile time, preventing dangling pointers and other forms of undefined behavior. Rust type systems separate shared immutable pointers of the form and "t" from unique mutable pointers of the form and mut "t". Immutable pointers can be coerced to an immutable pointers, but not vice versa. Music, nice one, yeah. Дурачок один, можеш, будь ласка, звук трошечки? So guys, ownership. Rust has an ownership system, and we've already spoken about it. And we're gonna continue by speaking of types and polymorphism. Rust type system supports a mechanism called traits, inspired by type classes in the Haskell language. Traits annotate types and are used to define shared behavior between different types. For example, floats and integers both implement the add trait because they can both be added, and any type that can be printed out as a string implements the display or debug trait. This facility is known as ad hoc polymorphism. Rust uses type inference for variables declared with the keyword. Such variables do not require a value to be initially assigned to determine their types. A compile time error results if any branch of code leaves the variable without an assignment. Variables assigned multiple times must be marked with the keyword. So, such variables do not require a value to be initially assigned to determine their type. A compile time error results if any branch of code leaves the variable without an assignment. Variables assigned multiple times must be marked with the keyword "but". Wait a second. So, let's continue speaking. A function can give generic parameters, which allows the same function to be applied to different types. Generic functions can constrain the generic type of implement a particular trait or traits. For example, an odd-bound function might require the type of to implement add. This means that a generic function can be type-checked as soon as it is defined. The implementation of Rust generic is similar to the typical implementation of C++ templates. A separate copy of the code is generated for each instantiation. It's called monophysization and contrasts each specific use case. The drawback is increased compile time and size of the resulting binaries. So let's continue speaking. The aliases including generic arguments can also be defined with the type keywords. The object system within Rust is based around implementations, traits, and structured types. Implementations fulfill a role similar to that of classes within other languages and are defined with the keyword implement. Traits provide inheritance and polymorphism. They allow methods to be defined and mixed into implementations. Structure types are used to define fields. Implementations and traits cannot be defined fields themselves, and only traits can provide inheritance among other benefits. This prevents the diamond problem of multiple inheritance as in C++. In the words, Rust supports interface inheritance but replaces implementation inheritance with composition, C composition, and over inheritance. Macros for language intentions. It's possible to extend the Rust language using the procedural macro mechanism. Procedural macros use Rust functions that are compiled before other components to run and modify the compiler's input token stream. These complements are declarative macros mechanisms, also known as macros by example, which uses pattern matching to achieve similar goals. Macros for language extension. It is possible to extend the Rust language using the procedural macro mechanism. Procedural macros use Rust functions that are compiled before other components to run and modify the compiler's input token stream. This complements the declarative macro mechanism, also known as macros by example, which sorry, I don't know what I'm speaking about. My full procedural macros come in three flavors. Function like macros custom, derived macros, attribute macros, custom attribute. The print-in macro is an example of function like macro and sets like bottom slash derive is commonly used library for general code for reading and writing data in many formats such as JSON. Attribute macros are commonly used for language binding such as the extender library for Rust blending for R. That was all I wanted to tell you guys for now. I love you everyone, put your likes, subscribe on the channel. That's all I beg you to do. So let's go to the next video.